All right, so this video is going to be basically talking about an example from the book, but the bigger idea is really how do you think about how totals relate to marginals and vice versa. So we're going to be looking at it as an example using a table format, then moving into a graphical format, and kind of explaining these larger ideas of totals and marginals. So from the book, there's the example of hours studying for an economics test and the total points expected to be earned from studying those hours. So we have the choices of either studying no hours up to 5 hours, and corresponding to each of those hours of studying is the total points that you would be expect to earn from studying those hours. So no study, no points. If you study 2 hours, the expectation is you'll have a total points of 32. 5 hours studying will result in a total of 50 points. Okay? So again, we're looking at hours of studying as your input, and the total points is the equivalent to what you'll see in the book as total benefit. Okay? So again, the idea is that this describes what your options are and what the output from those choices are, kind of this input-output idea. While that's a good thing to have, good information to have, what we tend to do in economics is we tend to analyze at the marginal. It's kind of marginal analysis idea. So the idea of the marginal analysis is really looking at, if we're at a certain point, what happens if we do one more thing? So that's what we call the marginal analysis. Doing one more, what's the change in the situation as a result? And that actually comes out from our total benefit or total points idea. So again, we could look at if we're studying 0 hours, we get 0 points. If we study 1 hour, we're going to get 18 points. So if we want to look at the marginal benefit of studying 1 more hour when we go from 0 to 1, all we're doing is comparing the total from studying 1 hour to the total studying 0 hours. So in this case, the marginal benefit is 18, going from studying, increasing our hours of studying from 0 to 1 results in a change of 18 points. So the marginal benefit of 1 more hour studying and going from 0 hours to 1 hour is 18. If we look at what's the marginal benefit of going from 1 hour of studying to 2 hours, we say, well, we know at 1 hour of studying we'll get a total of 18 points. We study 2 hours, our total points is going to be 32. So the gain from studying 1 more hour going from 1 hour to 2 hours is 14. And you can show to yourself why going from 2 to 3 is 10, going from 3 to 4 is 6 points, and going from 4 to 5 is 2 points. So again, we're looking at going from 0 to 1, 1 to 2, etc. These are showing that the gains in studying 1 more hour, they're all positive. So we're increasing our points, but what we're seeing is that as we study more, the benefit, the marginal benefit from studying 1 more hour gets smaller and smaller. Okay, so we've done that on the graph, on the table. So let's look at how it looks on the graph. So what I've done here is I've graphed the total benefit. On the vertical axis, we have the total benefit measured in points. On the horizontal axis, hours of study measured in hours. So, and all this graph is connecting the 1 hour of studying total of 18 points, 2 hours of studying 32 points, etc. So this graph, again, re-emphasizing this idea of describing all the possibilities, simply connects hours of studying to the total points gained. So we also have the marginal benefit, which we also created from the table. The only difference is according to the book and this idea of what we call the midpoint convention, is we had this idea of increasing our hours from 0 hours to 1 hour was 18 points. That was the marginal benefit. But the way we're going to graph that in this particular example using the midpoint convention is we're going to graph that 18 halfway between the 0 and the 1. So we're going to map it at 0.5 to give us 18. When we look at the marginal benefit of an hour of studying in going from 1 hour to 2 hours, the table told us it was 14. Again, we're going to graph that at the midway point between 1 and 2 at 1.5. We have 10 at 2.5, 6, and 2, etc. So again, this is all coming from the table that we created a little while ago. Okay, so now we've shown how the table connects to the graph, the next thing we want to do is how on the graphs the total can give you the margin. Okay? So what we have here is, again, the total, and in going from 0 to 1, we're still working with the 0 hours of studying, 0 points, 1 hour studying, 18 points, total points earned. So if we want to look at the slope of the line connecting the 0 hours and the 1 hour, we'll get change in total benefits over change in hours. So in this case, it's 18 minus 0, that's a change in total benefits, and 1 hour minus 0 hours gives us a slope of 18, which happens to be the marginal benefit. If we do the same thing for going between 1 hour of studying and 2 hours of studying, we have, again, we can do the same slope, and we get 32 minus 18, 2 minus 1, and that will give us a slope of 14, which again is the marginal benefit. And again, you can go through the next examples to figure out how this shows 10, 6, and 2. So what I've just shown you is how the total can give you the margin. Now the next trick is how to go from the marginal to the total. This will be a little bit different. So first thing I want to say is that there's this general concept, and it's much clearer if you've taken calculus, but I will show you an easy example here, is that if you have this idea of a marginal curve, a graph of a marginal curve, well, the area under that marginal will always give you the total. Okay? So we'll look at this example. We start with, we have our marginal benefit of 18 and going from 0 hours of studying to 1 hour. Okay? And we've graphed that at the midpoint. So what we're going to do is we're going to show this column here. So in 0 to 1, measured at the 18. So if we look at the area of this particular column here, that's going to be 18 times 1. So the area of this column, the area under the marginal curve, roughly speaking, between 0 and 1 is 18, which happens to be the total benefit at 1. Okay? So let's try the next one. In going from 1 hour to 2 hours, our marginal benefit is 14. So again, we're going to draw a column between 1 and 2. So width of 1, height of 14. So 14 times 1 gives us an area of 14. So the area under the curve at 2 means we have to add the 14 plus the 18 gives us 32, which is the total there. Okay? So what we've shown is that when we have the area under the marginal benefit curve at 2, we're roughly speaking adding the sum of these two columns, and it gives us the total. We do the same for 2 to 3. That gives us an area of 10. You can explain that to yourself. 6 and 2. So if we add, so if we're looking at the area under the marginal benefit curve at 5, what we should get is the total benefit at 5. So 2 plus 6 is 8, plus 10 is 18, plus 14 is 32, plus 18 is 50, which is a total of 50. So again, the idea is, generally speaking, the area under the marginal benefit curve will give you the total. If you look at the slope of the total benefit curve, it will give you the marginal. So the basic idea is that the totals imply the marginal implies the totals. They're just different ways of expressing the same information.